In this video, we'll be talking about quotient rule. A quick overview of the rule is that quotient rule is a way of differentiating the quotient or the division of functions. Or, it is also defined as the quantity of the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Or, as seen in the slide, it can be seen as y is equal to u over v being differentiated into dy with respect to d of x is equal to v times du with respect to d of x minus u times dv with respect to d of x all over v squared. Or dy over d of x is equal to u times the derivative of u minus u times the derivative of v all over v squared. One example of quotient rule being applied is in this example. Let's take the original function, f of x is equal to 8x minus 2 divided by x, and let's split it into two parts, u and v. We get that u is equal to 8x minus 2 and v is equal to x. Now let's take the derivative of both u and v, and we get that the derivative of u is equal to 8 and the derivative of v is equal to 1. When we put that into an equation, we get that f prime of x is equal to x times 8 minus 8x minus 2 times 1 all over x squared. We can multiply everything out to get that f prime of x is equal to 8x minus 8x plus 2 all over x squared. This can further be simplified down to f prime of x is equal to 2 over x squared as our final answer. A second example of quotient rule can be used with the function f of x is equal to 3x squared minus 2 all over 4x. When we split this up into two parts, we get that u is equal to 3x squared minus 2 and v is equal to 4x. When we take the derivative of both of these, we get that the derivative of u is equal to 6x and the derivative of v is equal to 4. When you put this into an equation, we get that f prime of x is equal to 4x times 6x minus 3x squared minus 2 times 4 all over 4x squared. When we multiply this out, we get that f prime of x is equal to 24x squared minus 12x squared minus 8 all over 16x. We can further simplify this down into f prime of x is equal to 12x squared minus 8 all over 16x squared. And since 4 can evenly go into all of these numbers, we can further simplify. A third example of quotient rule being applied can be seen in f of x is equal to 3x cubed minus 4x squared plus 6x all over 7x squared plus 5. When we split this into two parts, we get that u is equal to 9x cubed minus 4x squared plus 6x, and v is equal to 7x squared plus 5. When we take the derivative of both of these, we get that the derivative of u is equal to 27x squared minus 8x plus 6, and the derivative of v is equal to 14x. When you put this into an equation, we get that f prime of x is equal to 7x squared plus 5 times 27x squared minus 8x plus 6 minus 9x cubed minus 4x squared plus 6x times 14x all over 7x squared plus 5 squared. When we multiply everything out, we get that f prime of x is equal to 189x to the fourth minus 56x cubed plus 177x squared minus 40x plus 30 minus 126x to the fourth minus 56x cubed plus 84x squared all over 7x squared plus 5 squared. We can simplify this further into f of x, or f prime of x is equal to 63x to the fourth plus 93x squared minus 40x plus 30 all over 7x squared plus 5 squared as our final answer. Now, quotient rule is mainly used to find the derivative of an equation in which there is a variable that is in the numerator and the denominator. It is not normally used if the variable is only in one spot. Thanks for watching.